Welcome to Online Study for You. So, in mathematics, sexy primes are prime numbers that differ from each other by 6. For example, numbers 5 and 11 are both sexy primes because they differ by 6. Okay, so it was even mentioned in the examinations. This is nothing romantic about this word. Okay, so yeah, don't be in that thought. So now, in mathematics, so there are something called as sexy primes as given in the question. What it does means, the meaning of this is actually whenever there are two prime numbers which have a different 6, because 5 is a prime number. What is a prime number? So prime number is something that is divisible by 1 and only itself, and no other numbers can totally divide it, because you cannot divide 11 by anything, right? You cannot divide 11 totally by 2, because you'll get 10 and you'll get a remainder. So you cannot divide completely 11 by any other numbers apart from 1 and 11 itself. So those are called as prime numbers, and 5 is also a prime number. The difference between these two is 6, and that is why they are called as sexy primes. So we have been given a introduction about what is sexy prime. So now the question is, given a range of the form L comma R, that is left comma right, the task is to print all the sexy prime pairs in the range. I'm going to explain that in a bit. So we'll see the example input and output, then you'll come to know it, right? So these are the example input and output. So there will be two ranges given, left and right, and what you have to do is print all the sexy prime numbers which are within this range. For example, 7 and 13, the difference between 7 and 13 is 6, and these both are prime numbers. So this is a pair of sexy primes, and these are all the sexy prime pairs: 17 and 23, 23 and 29, 31 and 37, 53 and 59. So we have to write an algorithm or and devise a program that can do this, that is calculate all the sexy primes given two ranges, that is left and right. Some range is given. Okay, so that is what you have to do. Now let us go for the explanation of this code. I'm going to explain you again what exactly they are saying. Okay, so they are saying we have to write a program for sexy prime, right? So what again is happening in sexy prime, we have to note down that before getting on to the actual solution. So there is a number m and there is a number n. Okay, these both numbers are prime. The difference between these is 6. Okay, this is called sorry, this is called as sexy primes. Now what you're supposed to do is, they will, so this is a number line, right? This will be 0, this will be some positive infinity, this will be negative infinity. Now they will give you a range of numbers, say maybe as they have given 6 and 59, they will give you a range of numbers, and within this range what you are supposed to do is print all the sexy primes in this range in this format. Okay, so number 1, number 2 is separated by a comma, the next pair number 1, number 2, and so on your computer screen. Okay, so that is what your task is. This statement was very clear. I hope you have understood this. This is I have seen people writing very huge programs, maybe 20 lines, 40 lines, 30 lines of programs to solve this problem, but in reality this takes a very less number of lines of code, and it is pretty easy also to solve this program. Now, how do we solve this program? How do we devise an algorithm for this? So first what we have to do is we have to take input, that is we have to take L and R, that is our right and left and right parameters. Okay, now next what we are going to do is, I'm going to write a function called check prime. Okay, what this will take is an integer n and it will return either true or false. If the number is prime, it will return true. If the number is false, it will return false. Now what I'm going to next, what I'm going to do is I'm going to take a looping algorithm. I'm going to do a loop. Okay, I'm going to do a loop from L to R. Okay, so let us say L is 5 and R is 35. So we have to loop, right? So you can take I is equal to 5, and the next time I is equal to 6, so on up till I is equal to 35. So that is what you're doing. That is what you're doing, looping here. Okay, so here that is what you're doing. Now what I'm going to do is I'm going to say I'm going to check if I and I plus 6 are both prime numbers, right? So if both I and I plus 6 are prime numbers, they can be printed, sorry, they can be printed here on our screen as sexy primes. Okay, that is what we will do. We will we will loop from L to R, and we'll check if I and I plus 6 are both primes. If both are prime, print that prime pair onto the screen. Print the next prime pair onto the screen, and so on and so forth up to all your prime numbers. Okay, this is fairly simple. You may be a little bit confusing after listening to this explanation, but don't worry, we will code up this solution in a programming environment. So I'm going to go to my programming environment, that is code blocks. So this is called code blocks. This is my programming environment. This is a software which in which you can program, right? You can program, and then you can use this button to build and run this program, so you can see the output here itself. So if you're doing this in Linux, you have to have a separate editor, you have to have a separate terminal where you will call your compiler, but this is called as an IDE, integrated development environment, where you will do all those things here itself. So now let us include stdio.h, that is our standard header file, and I'm also including another header file. We'll include that later whenever we feel the need. So I'm going to say int main, okay, and I'm going to say return 0. This is our routine, so we have to pass a return 0. Now what I'm going to do is I'm going to say int L and R, that is our ranges left and right. Okay, so we need that here, so let me comment it down, range of numbers. Now I'm going to read those two numbers as an input, %d %l %r. So I'm reading those two numbers as an input from the user via keyboard. So user are going to enter these numbers. Okay, next what I'm going to do is I'm going to take a for loop. Okay, what I am going to say is I'm going to take a temporary variable int I, and that int I will begin from the left. As we said here, we're looping starting from the left to the rightmost number. So starting from left, the condition is left plus 6 should be less than or equal to right. Okay, I'll tell you why. Okay, now uh, so what we're doing is we want sexy primes. So what is it mean? It means the difference between those two numbers is actually 6. So that is why in our loop what we'll do is we'll take a number, so let us say 3, and what we'll do is we'll automatically add 6 to it. What is 6 plus 3? 9. And then what we're going to do is we'll first check whether these two numbers are prime. In this case, 3 is a prime number, yes, but 9 is not a prime number. Okay, let us take another one, 7 and 13. So what we'll do is our I value will be 17. Okay, I value will be 17, and what we'll do is we'll compare, we will add 6 to I, that will yield us 13, because we want all prime numbers whose differences are 6. And then we're going to check if these both two numbers are prime using a function. We'll write that function also in our program. If these two numbers are prime numbers, then we can say that these are sexy primes because the difference between them is already 6, as we know. And then these both are also prime numbers. Okay, so that is what we're going to do. So that is what we're going to say I plus 6, I did L plus 6, so that is wrong. So next what I'm going to say is if check prime of I and check prime of I plus 6 is true. So what is this check prime? Is a function that checks if the numbers are prime or not. So we have to write that function because there is no check prime function. So in order to write that, I will include a header file called stdbool.h. Okay. Why? Because I'm going to return a boolean variable. Bool check prime. It will take a number n as an input. Okay. So here what is bool? Bool is a boolean number. Okay. So a bool will have two possible values. The first one is true if the value is true. The second one is false if the value is false. That is 1 or 0. Okay, of this sorts. So if what I'll do in this check prime function is that I'll take a number n, and if it is a prime number I will return true. If it is not a prime number I'll return false. Okay, that is why I need this bool. Okay, and that is why I need this header file. Now let us only concentrate on this function as to how to check if a number is prime number. Okay, now let me take a different color for you. Let me go for the yellow. Okay, so now I want to check if a number is prime or not. How do I do that? Let us say a number 31. How to check if the number is prime or not? What is a prime number? The number should be divisible 1 by 1 and itself only, right? That is a prime number. Now how do we do that is we'll again loop. Okay, we'll again loop from 2. Anyway all numbers are divisible by 1. Okay, and all numbers are divisible by itself. What we have to do is we have to check that between 1 and itself, is there any number that will divide that number. Okay, so for example, if our number is, let us say we are checking 9, 1 already divide 9 and 9 already divides 9. Between 1 and 9 we have 3 which will completely divide 9 because 3 3s are 9, right? So that is what we have. If since this is there, 9 is not a prime number, so that is how we are checking it. So we are looping from 2 to actually n by 2. Sorry, we are looping up to n by 2. So why we are looping up to n by 2 is because again I'm going to erase all these things. So we are looping from 2 to n by 2. So n is any number for which we have to check the prime. So why we are looping up to only n by 2 is because let us say the number 50. This 50 is divisible by 25 because 25 twos are we have 50. So if you see 25 is exactly the half of 50. So if you say after 25 there are no numbers that are completely dividing 50. Okay, and if you see any non-prime number, the maximum number that totally divides that number is only up to n by 2, and after n by 2 you will not have any number that completely divides it. Let us say 100. So 100 is divisible by 50. After 50, 51, 52, to so on up to 99, no numbers will divide 100 except for only 100. Okay, so given a number n, only n by 2 can divide it. So from 1 to n by 2 up to n can divide it. Now what we have to check is it is okay if it is divisible by 1. It is okay if divisible by 2. It will be a prime number. We have to check in this list if any number is dividing n or not. If it is dividing, then it is not a prime number. If no number is dividing, it is a prime number. Okay, so our condition is to check from 2 to n by 2. So that is what we are checking. We will see if n mod I is equal to 0. So what is n is the given number, I is this looping variable. If it is dividing, then we'll return false. Okay, why? Because it is some number is dividing that number and it is not a prime number. So that is what we are doing in this check prime function. We'll say take a we'll take a boolean flag, okay, which will initially say true. Then what we'll do is, yeah, so then what we'll do is we'll say for int I is equal to 2 as we've discussed, I should be less than or equal to n by 2 I plus plus. So why again we are doing up to only n by 2? We could have done till 9. So since n is small, in our cases, it will not affect. But if n is a large number, say 5,000, 5 lakh, 5 million, our computer has to do a lot of computation and the program will become eventually slow. So in order to avoid that, we have to do all kinds of optimizations that we can within our limits to reduce the number of computations and get the good result. Okay, that is the reason what we are doing. So if I is equal to 2 to n by 2, if any number is any number mod divides this number, we say return false, which means the function will end here. Okay, that means the number is not a prime. If this condition does not become true, if it is not a prime number, so this statement will not only execute and this for loop will end, and we have to return this flag at the end. Initially this flag is true, indicating that any number given to it is considered as a prime number. Okay, if is divided by any other numbers, will return false. Okay, so this is just check prime function. Here again, if we come back, if check prime of I and check prime of I plus 6, that is the sixth difference number, is true. So what this will return? Either true or false, right? So if this is true and this is also true, true and true will do a AND operation. You know AND operation, right? Again, uh, we'll have to erase all this. So what we are saying here is we are saying if check prime of I and check prime of I plus 6. So this is similar to if true and true. If both are prime numbers, this check prime function, as we have seen here, will return either true or false value. And if both are true, true and true, that is 1 and 0, 1 and 0 operation will happen, 1 and 1 operation will happen, and this if condition will become true, and that is when we are going to print those two I and I plus 6 onto the screen as sexy primes. That is, we are going to say printf percentage d comma percentage d slash n. So here we are printing I and I plus 6. Okay, this is the exact program. Okay, so we are done with the program actually, so it will take only these many lines. This is so much simple program to write. Okay, so I hope you have understood this. We'll try to now run this program and see. So we'll see the sample input that was given. So 1 and 19 are the sample inputs. Now we'll run this program and see where any errors are there. So there are no errors. This program is computing successfully. So we'll say 1 and 19. What we'll get is, we see this, there is a small mistake in the program, and that is the reason why we're getting 1 and 7 also as the output. 1 is not a prime number. So what we have to do is, see, if you see the inputs here, there is no 1 and 7 that are mentioned here. Okay, 1 and 7 are not mentioned here. So we have to handle that condition also here. So what we have to say here is, if this number is equal to 1, we have to return false. By doing that, what we're doing is ensuring that 1 doesn't come in our output. Okay, now if we say 1 and 19, we are going to get 5, 11, 7, 13, 11, 17, 13 and 19. And that is also what we have here: 5, 11, 7, 13, 11, 17, 13 and 19. Next we'll test with 6 and 59. We're gonna end this. So next we'll try with 6 and 59. So after printing 6 and 59, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different pairs. And if you see here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different pairs. So our program that we have written is correct. Okay, so we have a check prime function that will check for a prime number, and we loop from L to R with a difference of 6. If both are prime numbers, we will say this is a prime number. Okay, so that is it in this video. Thank you for watching this video, and prepare well for the examinations.